You really don't have to know all of this theory to effectively use a vibration or impact tool. Just put it in the keyway, pull the trigger, and rotate your torque wrench at just the right time. You must be sure to make contact with each of the pins. When using an impact tool, make certain that you impact the center of each of the pins exactly straight on and at the same time. This means the blade must be exactly parallel to the keyway. Some tools have angled blades to allow holding the tool at an angle if space is tight. These will require a bit more practice to ensure that the blade is always parallel and strikes all pins simultaneously. Different locks will require a different amount of force for their pins to bounce properly. The locks must also be in good working order. If the lock is dirty, the pins may be unable to bounce freely inside their chambers. Chapter 3. Advanced Pin Tumblers, Rounded and Beveled, Master Keyed, and High Security Pins. Most locks you will encounter have to be affordable, therefore they will also be easier to pick. Manufacturers are always looking for new and innovative ways to make locks more secure. They are also looking for ways to make them cheaper. Because of this, you will encounter many modifications. Some will make your job easier, some harder. Higher quality locks are made to tighter tolerances. Picking these more expensive devices can be a challenging task that will demand more practice. Advanced lockpicking is an art that requires you to be in tune with yourself and the lock to pick up minute movements in the lock. There is less room for error and it will be harder to tell when the pins are set. Of course, sometimes the manufacturer will try to trick you by using different types of pins or holes. The ends of the pins that meet at the shear line are usually mostly flat. The key must lift them to the correct height to allow the plug to turn. Sometimes, though, this is not the case. These ends can be rounded, either to account for lower tolerances or to portray a false set. That is, the plug can rotate slightly, giving the effect as if it were set, even though it is still jammed in place. Loosen your torque slightly and try to jiggle the pins into place. Here, the bottom pins have a rounded top and can problematically jam slightly beyond the shear line. You have to stop pushing up on the pin exactly as it sets, or the rounded end can enter the hull. This will keep the plug from rotating. However, it will still turn some, and another pin column may begin to bind. Just loosen your torque and allow the pin to fall, or use your pick to jiggle it loose. Again, you may lose some other pins you had previously set, so you'll have to be careful and do them over again. Beveled holes can cause a similar problem. They can also work in conjunction with each other to make your job easier or more difficult. The pins can also get stuck on the bevel in the hole and cause another false set that mimics the reaction of a real set. Here we can see the pins being raised and the top pin jamming on the hole's bevel. You may have to rake over the pins a few more times or pick some of the pins a few times in order to get a lock with beveled holes and rounded pins to open. Depending on the design though, your job could be easier and the pins could slide into place with less effort. Ultimately, your persistence will pay off. Many installations and buildings have a large number of different locks that each need their own key. For example, each room in a hotel needs a different lock for each door. It would not be practical though for owners or maintenance personnel to carry that many keys. So there is usually one master key that can unlock all of the doors in a system. Picking these locks can actually be easier, however, since there are more pin combinations that can open each lock. These locks have extra middle pins in some stacks that allow them to rise to different heights, yet still break at the shear line. This allows two different keys with one or more notches cut to the correct second height to also work the lock. Usually the master key will lift the bottom pin to the shear line, while the user key lifts the middle pin to the shear line. This means the master key will have the shallower cut. Otherwise, someone could simply file down the correct notch on a user key to make a master key that could open all of the locks in the system. As you can see, there are more pin height possibilities, and you are more likely to get one right when you try to pick a lock that supports a master key. The more middle pins, the more keys the lock will work with. Thus, it is easier to pick. There may even be unintended combinations for which there are no keys. Often to compensate for the middle pins making picking easier, some of the normal pins will be replaced with special high security pins. High security pins are almost the same as normal pins. They serve the same basic purpose. They move up and down in the pin stack and separate at the shear line, just like their simpler brethren. They only begin to act differently when someone tries to pick them. These more costly pins will fool you into thinking you have set them, while they haven't really cleared the shear line at all. You will get that satisfying click and the plug will rotate just like normal. But something is amiss. The lock will refuse to open. The mushroom pin gets its name because its shape vaguely resembles a mushroom. The indentation in the side of the pin allows it to false set as it is being pushed upwards. The top edge of the head of the pin will slip by, mimicking the pin setting, yet remain stuck at the same time. Because it is the top pin that is set, the lower pin can still fall freely down, further maintaining the charade. Because it is the top of the pin that is stuck, you can no longer simply continue to push up. You will have to slightly release your pressure on the torque wrench.